Hi, hello everyone. Welcome back to NADAR'S Senior Voice channel. As you all know, we are in chapter 7. This video is continuation of chapter 7, Python functions. Welcome back. In my last video, I explained about functions using libraries. In that, I explained about built-in and mathematical functions like ABS functions, ORD function, that is ordinal function, character function, binary function, then type function, ID function, that is address, minimum, maximum, sum, right? And format function, then round function, power function. Then in mathematical functions, I explained about floor, ceil, and sqrt, right? And few of you asked, sir, you didn't show the practical part of this. So I will show that in this class, right? I have typed the set of things for you. This is ORD function, that is C is equal to A and D is equal to capital A, small a and capital A. This is ordinal function for that. And character function, F is equal to 65 and G is equal to 43. Whatever is given in your textbook, the same example I have taken. Binary, and X is equal to 15 and Y is equal to 101. So here, if you notice, I'm printing CH, that is ORD of C, ORD of D, and here character of F and character of G, and binary functions, the same thing, right? I'm going to run this. Now, after executing, what is happening, I will run it, I'll save it, and I'll run the program. I'm not getting the output. Let me check it. Okay, now see the output. At that time, I selected Python shell. Okay, when you select Python shell, it will not show the output, it will show only the shell. And run mode, and here you see, so 97 is small a, 65 is capital A, and 65 is equivalent is capital A, and this is 43, and binary of 15 and binary of 101. Is it clear? Understood, everyone? Right. Okay. Now we will see composition in functions. Today's topic is composition in functions. What is composition in functions? The value returned by a function may be used as an argument for another function in a nested manner. That is, the value, the output which you received from the previous function may be input for the another function, right? This is called composition. For example, if we wish to take a numeric value or an expression as an input from the user, that is when you're getting input from the user, we take the input string from the user using the function input. You all know that, right? And apply eval function to evaluate its value. See, this is a very interesting function which you can find in Python. It is not there in C++ or C. See here, n1 is equal to evaluate input enter number. You are giving 234 and it prints 234, right? And here you see n2 is equal to eval input enter arithmetic expression. See here, you are giving 12.0 plus 13.0 into 2. See, you are giving expression here, right? And see, Python gives the value for that 38.0. Is it clear? This is the use of eval function, evaluate. Okay, evaluate function. And Python recursive function. You know what is the meaning of recursive function? The function calls itself. When a function calls itself is known as recursion. Recursion works like a loop, but sometimes it makes more sense to use recursive than loop. You can convert any loop to recursion. Recursion means it repeats itself, right? A recursion function calls itself. Image, that is, you imagine a process would iterate indefinitely if not stopped by some condition. That is, indefinitely it evaluates, it repeats. So you imagine like that, right? Such a process is known as infinite iteration. Infinite means it goes on and on. There is no end for that. The condition that is applied in any recursive function is known as a base condition. A base condition is must in every recursive function, otherwise it will continue to execute like an infinite loop. That means why you have to give this base condition, you have to stop at once. At one stage you have to stop this recursive function, otherwise it will become infinite loop. Then you understood this. That is, you imagine a process would iterate indefinitely. That means indefinitely means without any condition. It becomes infinite loop. So you will not get the output. You understood? So overview of how recursive function works. Recursive function is called by some external code. If the base condition is met, then the program gives meaningful output and exits. When the base condition is met, suppose if example 5 factorial, right? You know that 4 into 3, 5 into 4 into 3 into 2 into 1. Once it attains all the number, that is 1 into 2 into 3 into 4 into 5, it stops. Okay, that is called a base condition. Otherwise, the function does some required processing and then calls itself to continue the recursion. Here is an example of recursive functions used to calculate factorial, right? Def is a keyword, fact is a function name, n is a parameter. If n is equal to 0, suppose if you give 0, it will return 1, right? Else it calculates. Okay, suppose I'm giving 5, right? It goes inside and it comes here. Now here you see I'm calling the function again inside the function. This is called recursive function. Now, right, n is 5. Okay, and here 5 minus 1, that is 4. So 5 into 4. Right, and then 5 into 4, 20. So here it will become 20. Okay, and 4 minus 1, that is 3. So 20 into 3 is 60. Now 60 will be stored here. And 3 minus 1 is 2. 60 into 20, that is 120. So here 120 will be stored. And 2 minus 1 is 1. So 20 into 1 is 120. So you are getting 120. Any doubt? Is it clear now? Right. Now print fact of 2000. 2000 will give runtime error. Maximum recursion depth exceeds in comparison. That is only 1000. By default it is 1000. 1000 times you can call any function. So you exceed the limit. This happens because Python stops calling recursive function after 1000 calls by default. Right? It allows you to change the limit using sys.set recursion limit. So using this function, you can increase the limit. Suppose if you want to exceed more than 1000, you can use this function. See here, import sys. See, you are importing this function, right? And sys.set recursive function 3000. Now if you call, okay, now if you call, it will not show any error because you already set the limit to 3000. You got it, everyone? Right? So that completes the chapter. Very important chapter. All the chapters are very important. Give equal importance to all the chapters, right? So I completed this chapter, and next is hands-on experience. Okay. Our next topic is hands-on experience. Try the following code in the above program. The program which I already explained. Okay, just I'll open the program, then you will understand. Yes, while explaining function, I explained this program. Def is a keyword, print info is a function name, and you have two parameters, right? Name and salary is equal to 3500. This is default value, and you are printing the same, right? And return. So function program completed. Now we are passing the parameter, passing the arguments now. Print info is the name, and I'm passing 3500. Remember here we are not mentioning this 3500 should go to which parameter. Okay, so already you have default parameter here. So name is not having any argument. So 3500 will be sent to name, right? And here 3500 and then two arguments you are passing. Okay, but remember one thing, computer is a dump machine. Okay, it will not know which argument it should take. Okay, it is not intelligent. You have to instruct. So here you are passing two arguments. First argument 3500 name will take, and second salary Sri will store in that. Okay, next what you are doing, name is equal to Balu. You are specifying name is equal to Balu. Okay, even though here you have default parameter, so name is not having any argument. So Balu will be sent to name. Don't think, oh, okay, when we give name, computer will identify. No, not like that. Is it clear? Then you are passing two arguments, Joes and 1, 2, 3, 4. First you are passing Joes, so name will take Joes. Second you are passing 1, 2, 3, 4. Now this is a default argument, even though it is default argument, right? From here, whatever argument you pass, because this is actual parameter, this is formal parameter. So 1, 2, 3, 4 will be sent to salary. And here you are passing space. Okay, nothing you are passing, right? And here you are passing 1, 2, 3, 4. So 1, 2, 3, 4 will be sent to salary, and first you are sending space, so name will get space. Can we see the output now? Can you see now? One second, let me show. One second. Yes, now you can see. Okay, so first we are passing 3500, and so name is taking 3500, and salary already 3500 is there, so you got 3500. Next you are passing 3500 and Sri. Okay, and name, see here it has taken 3500, and salary you see Sri. That's why I said computer is a dumb machine. Unless you specify, it will not print properly. Okay, you will not get the output properly, right? Next you are sending name Balu. So Balu, even if you don't type name also, it will take. You will see now. Save, and then I'll close this. Once again, I'll close this, because otherwise it will print below that. Okay. Okay, right. Now I'm going to run it. Got it? Now see, I'm sending Balu. So you got Balu here, not because of name is equal to Balu. Keep it in mind. And next to Joes and 1, 2, 3, 4. So name has taken Joes and 1, 2, 3, 4. Next you are passing a space. So name is having space, and salary 1, 2, 3, 4. Is it clear, everyone? Okay, the second one, evaluate the following functions and write the output. See, evolve, already you have seen that. Okay, right? I'm going to type the same thing. Let me see. Right, I'll minimize it, and we will see what happens. Right? Okay. Now, EVAL open bracket single quotation 25, right, into 2 minus 5 into 4, single quotation, close it, single quotation, close it. Okay, now you press enter. Okay, how you got 30? 25 into 2, 50, right? And then 5 into 4, 20. So 50 minus 20 is 30. Is it clear? Right? Right. Next, math function. Already you know mathematical functions, built-in functions, and mathematical function. Mathematical function, some mathematical, that is some mathematical functions will use math function, and some doesn't need math function like ABS, ORD, CHR, binary, type, function, minimum, all these things doesn't need math library. But floor, seal, and SQRT function requires math function. That means you have to import math. Now here you see, let me type like this directly, MATH dot SQRT bracket ABS yes minus 81, close the bracket, enter. What happened? Can you tell me? Because I have not defined math function, so you have to import math. Now if I type math dot SQRT ABS of minus 81, close it. Got it? Right? So if you want to use a SQRT function, you have to import math function before. Otherwise you will get error. And here ABS of any negative number, absolute value will be positive number, minus without sign, I mean 9.0. Is it clear? Right? Next, math dot seal bracket 3.5 plus 4.6. Okay, now enter. 9. How you got 9? Can you tell me? Can you tell me? Seal will return the integer greater or equal to the number x. So 3.3 and 4 is 7. 5 plus 6 is 11. So 7. Come on, mathematics. Everyone should know. Right? Come on, tell me. Got it? Come on, 3 plus 4 is 7. And then 5 plus 6 is 0.5 plus 0.6 is 11. So 7 plus 11, 8.1. So what is the definition for seal? It returns an integer greater than or equal to x. Greater than or equal to x. That is 8.19. Okay. Right? Already I explained about seal and floor. Keep it in mind. Here, because already I imported math, so that's why it doesn't require to import again. Is it clear? One more. Math dot floor. Floor is just opposite, right? Same thing I'm going to give. 3.5 plus 4.6. Okay. Now lesser than. Floor returns an integer lesser than or equal to x. X means this. This is considered as x. Is it clear? Right? And next one is evaluate the following function and write the output. ABS. One second. The control AB. Okay. Right. ABS of minus 25 plus 12.0. Right here, if you notice, they had given 2 brackets. If you use 2 brackets, definitely you will get error. And here, if you notice, minus 25 plus 12 is 13, 13.0. Absolute means it will not give any sign, whether positive or negative. That's it. Okay. Next one is ABS of minus 3.2. As you all know, it will remove the sign. Okay, is it clear now? Right. Next, ORD. Okay, ordinal. Right. Yes. So this is, as I told, this is opposite to char. ORD is opposite to char. That means the value, that is number equivalent of the character is 50. Is it clear? The number equivalent of the character is 50. Okay, next one is ORD, ordinal of dollar. So ordinal of dollar equivalent is 36, right? So next type will give the data type of particular value, whatever you are giving, right? So it should give string. Is it clear? Next is binary of 16. Okay, so this is a binary of 16. Decimal 16 is 10000, right? And next char, one second, char of 13 slash r. Okay, slash r is nothing but the carriage return, that is enter key, right? And it is also called as new line. That is, if you want to move the line to the next line, you can give slash r. Usually we give slash n. Okay, have you understood? Okay, right? Yeah, next is same thing. Print char of 13. Nothing. See, already print char of 13 is carriage. See here, it left one space. Is it clear, everyone? Next we will see round of 18.2, 1. That is, I want only one space, but after decimal you have only one space, only one decimal number, so it is printing 18.2 as it is, right? Now I'm giving round of 18.2, 0, right? That is, I don't want anything. I want 0. I don't want 18.2. I want only 18. Okay, it is rounding off. Is it clear? And next is a round of 0.5100, 3. I want 3 digits after decimal. So 0.51. Okay, only 2 have taken because it is trying to round off, right? And here you see 0.5120, 5120, 3. Now see here, it has taken 3 digits after decimal. It is printing 3 digits after decimal. Is it clear? Next is a format function, right? Format function. This one. Format 66, C. I thought of showing it in the program, using program, but directly I can use the mode. What mode? There are 2 modes. What mode? Script mode and, come on. Yes. Okay. Now direct mode, I'm going to type format, right? Format, right? 66. I want in character. It is B. You know, 65 is capital A, 66 is capital B. Next, 10 in hexadecimal. A. Okay, 10 equivalent in hexadecimal is A. Format 10 capital X. Okay, right? Now hexadecimal for 10, right? That is what you are doing here. See the difference here. 10 in small x is small a. 10 in capital X is capital A. You understood, everyone? Next is format 0B. You know, binary, right? 1 1 0 to decimal. So this is binary to decimal. So 110 in decimal is 6. Okay, and the 5th one, I want everyone to try it and fill it. Okay, Fifth one, you have to do it. Okay, the last one is power of 2, minus 3. Okay, 2 to the power of minus 3. Right? So it is 1.125. Same way, power of 2, 3.0. Right? 2 to the power of 3. 2 into 2 into 2. That is 8. 8.0. Right? Power of 2, 0. So anything to the power 0 is 1. Okay? Right? Next one. Power of 1 plus 2. Okay? 2. See here in your textbook they had given one bracket. Suppose if I give that bracket, it will give error, I think so. Bracket, 2. Got it? Understood? Right. Next is power minus 3, 2. That is, it will remove the negative sign. Okay, don't worry about that. Power of 2 into 2, 2. Okay, 4. 4 square. 4 into 4, 16. Okay, everyone. So, that completes hands-on experience of chapter 7. Okay, and children, just to go through each and everything. Still, if you have any doubts, you can ask me. Okay, children, see you bye in the next video. Thank you.